Hey guys, we are in our free online coaching classes for the NET examination, and this video will be the lecture 5 on this series. And the topic is the structure and chemical composition of the atmosphere, and the book which I referred is The Atmosphere, Ocean and Climate Dynamics by John Marshall and Climatology by John E. Oliver. As we had started with oceanography, we had covered 4 lectures in that, and now we will try to start the atmospheric science. And this is the very first heading, an introduction to atmosphere. Actually, air is a mixture of permanent gases such as N2 and O2 in a constant ratio, together with some minor constituents. And here is the table which shows the overall constituent of the atmosphere. You can see N2 is a dominant constituent which consists of 78%, followed by O2 which is 21%, then argon, then water vapor, then CO2, like that the list continues. The composition of the air is a direct consequence of the supply of elements from the Earth's interior that we know, because anything that is in the atmosphere will be from the surface of the Earth, right? There will be very less probability to get something which is not on the Earth but in the atmosphere. And the presence of life on the surface will also control and contribute to atmospheric composition. Let us give you an example. The photosynthesis by the plant makes O2 and nitrogen compound from the living organism or returned to the atmosphere as N2 from metabolism, and the lightning convert N2 into usable molecules for life. Two of the most important minor constituents are the H2O and CO2, that is the water vapor and carbon dioxide, because this plays a central role in controlling the temperature of the Earth's surface and sustaining life. As you know, the greenhouse effect, if there is no presence of water vapor and carbon dioxide, the mean temperature of the Earth will be somewhere near minus 15 degrees Celsius, where there will be no possibility of living organism. And due to this greenhouse gases such as CO2 and H2O, the Earth's average temperature is say plus 15 degrees Celsius, and that is why life is present in the Earth. And that is why it is called as greenhouse gases, that you know, right? And the atmospheric water vapor is present in a variable amount. Say for example, the range is somewhere near 0.5 percentage, that you can see approximately I mentioned 5 percentage by volume, and it's primarily the result of evaporation from the ocean surface. As you know, the earth is covered by the ocean almost 70, more than 70%, right? And unlike N2O and O2, water vapor to a lesser degree CO2 is of great importance in radiative transfer. What is actually radiative transfer? The passage of radiation through the atmosphere is called as radiative transfer, because of the strong absorption and emission of the infrared range somewhere near say 10 micrometer. And the water vapor content of the atmosphere at any point mainly depend on the temperature. Actually, the temperature is the main controlling factor of the presence of water vapor, and according to the temperature the amount of vapor may be determined. And to some extent the atmospheric pressure also controls the amount of water vapor and also the proximity of the moisture source. And the water vapor content is normally highest close to the surface, and the reason behind this is first the evaporation on the ocean surface and evapotranspiration by the plants and animals, right? And the second reason is that the normal air temperature is actually high near the surface, and when the temperature is high, the moisture content, that is the water vapor present with this, will also be high, and that is why you can expect a large amount of water vapor that will be near the surface of the earth. And the air closer to the surface is actually subjected to the mass of gas that is lying above, and hence the greatest portion of the mass of atmosphere lies the surface. Atmospheric pressure decreases exponentially. As you move from surface to the top, the drop in atmospheric pressure will be exponential, that is in the power, right? Let me give an example. The surface pressure in the earth surface is somewhere near 1000 millibar, and if you move say the lower up to the lower stratosphere, so that is somewhere near 15 kilometers from the mean sea level, the pressure is dropped to 100 millibars, which is say 1/10 of the pressure on the surface, right? Not only that, of the total mass of the air, you can expect 50% of the mass of the air that lies in 5500 meter, that is say 5.5 kilometers, within 5.5 kilometers from the surface, and almost 84% of the total mass of the air is just below 13 kilometers only, and almost 99 percentage of the total mass of the atmosphere is just up to 30 kilometers from the surface. And the density is also decreases if you go to high, right? And the gas stay roughly in the same proportion up to the height of at least 80 kilometers. That is what we had mentioned left side, right? So in this ratio that is in the table will be uh, same, say up to 80 kilometers from the surface. And the atmosphere may extend up to 1000 kilometer. It has been classified according to the physical as well as the chemical properties. And let us see one after the other. So the vertical structure of the Earth's atmosphere is given in the left side. The image is there. The first layer on the surface is called the troposphere, and which is very turbulent zone. Actually, the movement of air is very high, so it is a very turbulent zone. And the lapse rate is say 6.5 degrees Celsius per 1000 meter. That is, the lapse rate means the average rate of change in temperature with altitude. So as we move from the surface to the height, if you move say 1000 meter vertically high, the temperature drop will be say somewhere near 6.5 degrees Celsius. And the troposphere has been classified into two subdivisions. The first one is the lower troposphere, and the second one is the upper troposphere. Actually, the lower troposphere extends from the surface to up to 3 kilometers, right? And this zone is most affected by the daily changes. The diurnal change and the daily changes will affect this region only. And here is the maximum friction between the earth's surface and the atmosphere is taking place. Actually, the atmosphere will get in contact with the surface, that is the lithosphere as well as the hydrosphere in this region itself. And this zone most affected by the daily change in the surface conditions, and that may leads to the temperature inversion. That is, say for example, as we mentioned earlier, if you move from surface towards high, there will be a drop in temperature somewhere near 6.5 degrees Celsius per 1000 meter. That is what we mentioned, right? And in the lower troposphere, this may get inverted. That is, the temperature may rise at some time due to some different conditions on the atmosphere. This is possible only in the lower troposphere. And let us see the upper troposphere properties. It extends from 3 kilometer to 11 kilometer, and this is very less affected by the daily changes. As we mentioned earlier, in the lower troposphere it was highly affected by daily changes. Here in the upper troposphere the daily change will not be very high, and the primary change in this region is due to the atmospheric storms and the seasonal change, and these are the two main changes that takes place in the upper troposphere. And the tropopause marks the boundary of the troposphere, and it is significant because it marks the upper limit of the turbulent zone. That is, if you cross the troposphere, that there will be the tropopause, and above that there will be no much movement in the air. And if you cross the tropopause and moves down, the wind will be very turbulent. So this marks the turbulent wind and the very literally moving or even not moving wind. And it also marks the upper limit of the most of the water vapor. That you can see the clouds formation and the main type of rainfall water, the amount of water vapor will be very high below this tropopause, and above this the cloud formation, that is the presence of moisture or water vapor, will be comparatively very less. And at the equator the tropopause is at the height of say 17 km from the surface, and in the temperature range may be like minus 70 to minus 85 degrees Celsius, and the pressure average is just 100 millibars, that is 1/10 of the surface from the mean sea level. And if you see the same thing in the polar region, the tropopause will be at the height of say 9 to 12 kilometer, and the temperature ranges may be like minus 50 to minus 60 degrees Celsius, and the pressure is around say 250 millibars. So these are the two different conditions, and the equator and the pole. That you know the reason, because the equator is little bulged and the gravity in the equatorial region will be comparatively high, so it can hold a large amount of atmosphere, that is even the gas. And in the polar region, the gravity will be comparatively less, and that is why the height of the troposphere is say 9 to 12 kilometers. And the second layer, that is the stratosphere, and that is above the tropopause is the stratosphere, and this layer is, and in this layer what happens, the wind, that is the gases are in stratified form, and from that it got the name stratosphere. When compared to the troposphere, you can see that it is relatively stable. As we mentioned earlier, the troposphere is highly turbulent. Here in stratosphere it is relatively stable, and this is dry. As we mentioned earlier, the water vapor content in the stratosphere is comparatively less than troposphere, so this will be dry. And a little vertical motion, so there will be no much vertical motion. The motion in the stratosphere will be very little, and some high wind occurs just above the tropopause. Otherwise wind are noticeably absent. The moving air is called wind, right? So in the stratosphere there will be no much moving air, so there will be no wind formation. When there is a very high, very effective storm in the surface, that may sometimes affect the stratosphere. And the temperature is nearly same up to 20 kilometers, say from 15 to 20 kilometers, the temperature will be same. And after that, what happens, it will increase at the lapse rate of up to 4 degrees Celsius per kilometer. So the in the troposphere what you saw is a drop in temperature. In the stratosphere you can see the rise in temperature. And the upper region extends up to say 50 kilometer, and it is marked by the stratopause, which is a transition zone. And the next one is the mesosphere. Actually it begins at an elevation of about say 48 kilometer, and the decline in temperature will continue up to 80 kilometer. That is in the mesosphere there will be a drop in temperature, and up to the mesosphere you can see the mixture of gas is about the same as the surface. That is what we mentioned earlier. Up to 0 to 80 kilometers, the composition of the air will be somewhat equal, roughly equal, and that is why it is called as homosphere, as the overall composition from the surface to the 80 kilometer, that is the mesosphere, the composition of air will be somewhat equal. And above that what happens, the gas tend to stratify themselves according to the molecular weight. So the very high molecular weight will be lying closer to the mesosphere, and very light molecular weight elements like hydrogen will be lying away from the mesosphere. And this layer is called as the heterosphere. You can see in the left side image, from the surface to the top, the layering of elements, layering of the atmosphere. To a height of say up to 220 kilometers, the molecules of nitrogen largely make up the atmosphere, and the layer of oxygen and helium exit outward from there. So the mesosphere merges with the zone called the ionosphere. It actually consists of ionized gas and free electrons resulting from the absorption of solar radiation. And above this, perhaps say up to 1125 kilometer, the oxygen is prevalent, and after that say up to 3540 kilometers there will be presence of helium, and still further hydrogen atom is predominant. The boundary among these zones are not clear defined. And I hope this is the overall outline of the vertical structure of Earth's atmosphere and the chemical composition that we had seen. And as mentioned earlier, I had started the WhatsApp group, and if you want to join, you can just mail me your details so I can let you join in the WhatsApp group exclusively for the NET exam, where you can get the notes and study material for which I have shared here. And I group my videos according to the category that you can check in my playlist. You can connect with us by mail, Facebook and Instagram, and these are the links. And you can also support us by like, share and subscribe. Thanks for watching. Have a great day.